Hello everyone, Adam here from Vector3D. In this video we're just going to do a kind of best of and roundup of other things at the show that I didn't get to do interviews of. This first printer we're taking a look at is the X5 by Tiertime. The footage is playing back at 50% speed, which is why it looks a little bit slow. If you know the Cetus 3D printer, everything probably looks quite familiar. That's because they tend to take across a lot of the design language from one machine to the next. The thing about this printer that interested me is the fact that it has a automatically switching bed plate system. So on the right hand side of the printer there's a stack of 12 beds, and then in the center you obviously have your main bed carriage, which is where it's heated, and then it has this kind of automatic switching mechanism where it's basically pushing one bed out with the new bed. It kind of just repeats the process again and again and again, gripping and pulling until the old one falls out the end and the new bed's ready to go. This is probably going to be particularly useful if your prints are running 24/7. You could probably fill up the entire build plate with whatever small widgets you're trying to print, and then set it to maybe print 12 of those all in a row, and suddenly you've got 12 times however many you fitted on one build plate, all in one go without any interaction from a user. At this moment, I don't know how easy it is to actually top up those print beds in the stack while it's actually printing still. If you can, then that really is a fairly powerful tool for continuous printing in an industrial environment. Next, let's move on to the Raise3D E2. Now, this is a machine that I saw as a pre-production unit at TCT in Birmingham, but this one definitely looks much more production ready. It looks like the actual the final unit. Unfortunately, again, didn't get to do an interview. I did try my hardest, but unfortunately that didn't happen. It continues to look like a very promising machine, given the specifications. For example, it has IDEX, so independent dual extrusion, auto bed leveling, you can see the screen, it has an enclosure, it has places for filament to go during the printing, it has a fairly large volume given the overall printer size, you can see the filter in the back there, so it's got a lot of hardware that could potentially make it a great machine. We just got to wait and see to see what actually happens. The Prusa Mini was also available to see at the show. Now obviously this is a very promising little machine that's going to be released very, very soon. It's designed to have a lot of these smart features like in the Mark III, similar reliability, but being much more affordable, and I think the price range is somewhere around $350 to $400 depending on the options that you go for. Now critically, this was my first time to actually look at the machine in person, and I'm pleased to report that it looks a lot more sturdy in real life than it does on camera. Now this is playing back at 50% speed, which is why it looks particularly slow, but when I was watching it at the show it was going at full speed and it looked to be printing at a very reasonable speed. Regardless of the cantilever design, it does seem remarkably rigid. I think the bed must be very, very light, as that is preventing any of the kind of swaying that could occur on that extruder head. Also, that extruder is really, really lightweight. There's very little material there. You've got kind of a very lightweight aluminium heatsink with the hot end kind of attached directly to it and a fan blowing through it. There's not a whole lot more there. There are only two bearings, so it's really, really lightweight, and that again contributes to the lack of wobbling. One of the other things I was looking out for, particularly when I was there, is the screen. Now, initially, for some reason, I thought it was a touchscreen. It's not. I mean, that should be evident. It has the click wheel on the front, but it is still very quick and responsive. While I didn't use it myself, I was watching somebody else use it as they were setting up this print, and it did seem very quick, and there didn't seem to be any lag when selecting files or anything like that. So it does seem like the performance is definitely improved from that point of view. Of course, this is not my review of the machine. This is just literally first looks of what I saw and could observe while being at the show. I do have one on pre-order, and I ordered it within like the first hour, so hopefully that's going to be shipping to me very, very soon. This next one was a nice little surprise from Buildtak. As you may already know, Buildtak have their standard what's known as the Buildtak Surface, which is the black textured. They also have an adhesive PEI. But what you may not know, because it's not been released until now, is that they now have a nylon surface. So this is a material that's not made of nylon, but a surface that's designed for printing nylon. As you can see from what they were printing, these are large nylon frisbees being printed on the Raise3D Pro 2. So a fairly large kind of, I think it's probably maybe 250, 300 millimeters. Not totally sure what the build volume of the Pro 2 is, but it was a fairly large piece of nylon being printed, and there were no obvious signs of warping, so clearly it was sticking rather well. If I remember correctly, the price of this is probably going to come out around the same sort of region as the PEI coated surface and should be released fairly soon. Before we continue with the second half of this video, I wanted to give you a quick look around Formnext and also to give you an idea of just how enormous this exhibition is. In order to do that, I took this hyperlapse footage. Now, although it's going to play through very quickly, it was about half an hour, 40 minutes of continuous walking at quite high speed in order to capture this. The show is laid out across 4 halls on 2 different buildings, each on 2 different floors. So here is the transition where I'm going from one building to the next, and obviously the elevators is the transition between the 2 floors in each building. While we're looking through this time-lapse, don't forget to subscribe if you've enjoyed the content you've seen so far and you want to see more. Obviously, also like it if you enjoyed it, that way I know it's worth me making the investment to do these sorts of trips again. If you see a company that you know, feel free to leave a comment down below with the timestamp where you found them. Next we have the Transform, a large format MSLA printer from Phrozen, spelled P-H-R-O-Z-E-N. This is a 13.3 inch MSLA printer that is soon to be released, so is on pre-order now. You can use it either as a single 13.3 inch screen or as dual 5.5 inch screens. The XY resolution comes out to around 75 or 76 microns ish. And if I kind of work backwards, I think that makes it a 4K 13.3 inch screen. As you might expect, it uses a fairly standard FEP film and UV LED array kind of arrangement, but it does seem to use some LED optics to try and improve the uniformity of the UV light over that whole surface, which is good. At first glance, the print quality by resolution looked good, but by accuracy and by consistency didn't seem quite as good. There were definitely some signs of significant warping at the bases, so not sure why that would happen. Overall, it seems fairly interesting, but only time will tell if it befits its $1,600 price tag. Next up, we have the Igus booth. Now, Igus make plastic bearings and bushings and things like that, but they also do other motion-based components like drag chains and, well, other stuff that you might need in a motion system, rails and that sort of thing. So this is just a look so you can see what a correctly done energy chain or drag chain looks like. And then this top part of the image has this demo that they were running, which was basically just having these 2 cables run through this drag chain, and it was moving back and forward at varying paces, just literally all the time. It was constant. So that's it was quite an impressive demo just to show what you can do when you've got your energy cables, energy chains, drag chains set up, configured correctly. They also had some comically large drag chains there. So, I mean, these were absolutely enormous. Obviously not designed for your hobbyist 3D printer by any means, but they just looked interesting to me just based on their absolutely enormous size. So, of course, I picked one up just so you can see for scale quite how ridiculous the size is. It is absolutely huge. It wasn't too difficult to lift, but it was kind of awkward to pick up. It's pretty big. So next up we have BLB Industries, which is a company based out of Sweden that makes these large format printers called the Box. So they have a small, medium and large version, and the one you see in the shots here, the one they had at the show, is the small one. So that has a build volume of 1.5 meters on the X, 1 meter on the Y and 1 meter on Z. So yeah, that apparently is small. Layer heights on that printer go from 0.4 to 4 millimeters, so some pretty thick, massive layers. They have a number of different extruders, so you have a small, medium and large extruder. The small one does nozzle sizes of 1 to 2 millimeters at around 1 kilogram an hour, so that's an entire spool for consumer printers in 1 hour. The medium one, 2 to 8 millimeter nozzles, and that'll do 14 kilograms an hour. Yep. So then the large one then, starting at 8mm nozzles up to 14mm nozzles, and that material output is 30 kilograms an hour. That's like 30 entire spools of filament every hour. So yeah, needless to say, this is a pellet extruder, not a filament one. You'd be absolutely churning through filament if that's what you were doing. It does have a heated build plate, so it can do all your polypropylene, ABS, polyethylene, PLAs, nylon, etc. It has a very thin aluminium sheet on the top. I think it was aluminium, or was it steel? It has a thin metallic sheet on the top, certainly, which is their like removable, flexible build surface, if you like. It's held to the table using a vacuum, so it's sucked down under a fairly small vacuum, but it just sucks it down enough to stop it curling. That's obviously an alternative to the magnets you tend to see in the consumer printers. Obviously, by using a vacuum, I'm sure there are a number of other challenges, but it means you're not limited on the temperature as a result of Curie temperature of magnets. I mean, different magnets have different Curie temperatures, but whatever. The largest box they do is up to 2 meters on the X, 2 meters on the Y, and 1.5 meters on the Z. Other than that, I think specs are generally similar in terms of speed and layer heights. This one goes up to 7 millimeters. Obviously, that's because you can fit the very large nozzle. The maximum weight of the printed item, given that you can extrude at some ridiculous 30 kilograms an hour, has obviously got to be quite high. So this large printer can do prints of up to 1 ton. Yep, 1,000 kilos on a single print. The reason I found this interesting is just because nothing seemed overly complex about the machine, or like excessively complicated. It all seemed stuff that I was mildly familiar with, but just really ratcheted up to 11. Well, more like 11,000, but just everything just turned up really, really high. So yeah, it was just kind of cool to see something quite simple but quite effective, really big, and really pretty cool. Thank you very much for watching. Don't forget to subscribe for more content from Formnext 2019. I'll see you in the next one.